Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back for another live edition of the Bill and Corey Show. This is live show number 97.
Whoa.
So the countdown's on. And this is National Engineers Week.
Yes.
That's why we're wearing our official team hats.
Our engineering hats, because as we know, the only way to officially become an engineer is to drive a train
Right.
once, at
So
least once.
We
That's all it
drive a
takes.
train. Today we're going to talk about purging.
Yes. It's a great movie series. I like the third one the best.
I don't know that movie. That's pretty.
Wait, that's not what we're talking about here?
No, we're not. It's not movie
Oh,
stuff.
man, I am not prepared then.
Okay.
Uh-oh.
Okay.
Uh-oh.
We're going to talk first about process gas purging. So there's a lot of different purging we're going to talk about. Process gas purging, inert gas purging, and then like a line purge and a cycle purge.
But it's all gas purging.
Yeah, it's all gas purging. So you want to toss up the first graphic. Here we go. Here's a switchover system, one of our standard ones. That one of the options you can get is a high pressure vent valve option.
Which that doesn't say purging valve.
Right, you're venting.
No,
you're
that's a
purging.
good point. Yeah,
Well,
but
you
that's the point. It's interesting.
That's the point. It's
Yeah.
not just I feel like just venting it. So this is used. People want non-toxic gases, typically. When you want to, well, this can be piped away. too.
Yeah. The key is if you're gonna vent,
So-
purging and venting of safe locations. You gotta vent it to a safe location.
yeah.
That's the main theme.
Yeah, even if you're purging out like nitrogen, you don't want to.
100% nitrogen is just as deadly as.
You don't want someone. Well, you don't want someone standing right next to it
No,
and get
no.
blasted with nitrogen.
No.
Clear out their ears.
Well, and who knows? Maybe they.
So the idea being
Pretty
is you have the process gas and you're purging out the air that's in there.
Yeah. Venting, purging.
Venting, purging. So you want to do something.
Synonyms, as they say in the English world.
Or something. Okay, you can take the graphic off. So that's that. So that's just kind of part of it.
That's the basic.
Basic kind of purging. So we're going to talk about inert gas purging. And the first one we're going to talk about is line purging.
And inert gas obviously means gases that don't react. Non-reactive gases, essentially.
Correct. No.
Well,
That's purging with an inert gas.
Purging with the inert part, though.
Yeah, so it's like nitrogen typically. Sometimes we use argon, helium.
Helium, yeah. If you're fancy.
Yes. So to show that, we're showing a cross purge.
Because it crosses.
Because it's, yes. And you got, you would have your inert gas coming up here, and there's a check valve that keeps your process gas flow from backflowing into your...
So before you can, so if you open this valve, it's
so
not
you don't
just
get
gonna,
your peanut butter mixing with your chocolate. So for a line purge, you would have, let's call it nitrogen come in here. This is hooked up to a cylinder. You'd open the valve, and you just have gas flowing through there. That's the kind of purge a lot of people think of, is I'll just blast my nitrogen through there. It does a great job of cleaning everything out. You get a high velocity, you feel really good about it.
It makes sense.
It makes sense.
And
you have it vented downstream or whatever.
Yeah.
You know, this is your process.
You're fun. I mean, just like when it, you hang your clothes out on a dryer, out on the line to dry.
Yeah.
A windy day, it dries
just
faster
works,
than a non-windy day.
Right, exactly. The line purge works great, except when you have what's called dead legs. So you've got pressure gauges here are off the main path, so the gas flowing.
Or the road less traveled.
Is a road less traveled. It's like a little cul-de-sac here.
Yeah, there you go. It's a
cul-de-sac.
Yes.
So if you
and if you think about it like snow, right? Trying to plow out a cul-de-sac.
Oh yeah.
No, but that's a perfect analogy. We stumbled on an amazing analogy.
Okay.
I don't care. I'll admit it, Bill.
Okay, so these are dead legs. So if you have impurities in your gauges and you just line purge it, you're going to get some of them coming out. You're going to Venturi them out. But you got, and you got like this dead leg here. It's not much of one, but you're not going to get you're not going to purge out really that gas. That's not much.
Yeah. And it's an added dead leg from the cross purge.
Yeah. So that's the problem. Line purging works great when you have just a straight line and you don't have to worry about, you don't have any dead legs to it.
Mm-hmm. So in some gases they don't use gauges if they don't want to. So or is that later?
Actually, that's later.
All right. I'm
so
jumping
I'm going
the
to show.
gun.
I wish we could zoom in on this, but you can say pressure gauges. I got one BA dead leg. So you got this Bourdon tube, and we talked about
Bourdon or Bourdon?
Bourdon. I don't know. I'm not good with my French.
Bourdon sounds like a Star Trek enemy.
We covered this in some other show.
I mean,
some
everything
French guy came up with an idea for pressure gauges. Mm-hmm. So it's a curved tube. This is a brass gauge. It's one we had apart. Obviously, high purity system would be stainless steel. Same idea though. Just this kind of curved metal, and when you pressurize it, it expands and the needle goes. That's how it all works. So it's kind of neat. But
it's neat but simple.
You got a dead leg here that's tough to purge out. Mm-hmm. So like you said, some systems are like, if we don't need a gauge, don't have a gauge.
Yeah.
Because then you don't have to worry about that dead leg.
But if you still want to know pressure in there, what do you use instead?
Or you could some people use pressure transducers.
Yeah.
Because they're like a flat face seal. There's not much dead leg.
Yeah, and it.
You're going to need to hook it up to a controller or some readout to see.
I mean, it's like a diaphragm down there. Just push it up. Essentially, that's all it is.
So it's not much of a dead leg at all.
So
it's a lot easier to purge. Okay, then we're going to get into.
Sounds.
We got a lot to cover here, so that's okay.
It's not. No, this is fun.
So line purging is great, except
for dead legs.
For dead legs. So if you got any dead legs and you're concerned about getting the impurities out, use I should have gotten you hold this. But I'll hold this, you talk. So this is a cross purge on a regulator, and this is kind of heavy. It's about 6 pounds. That would hurt if it dropped on your head.
Bill's just trying to justify why his arms are getting tired out
loud. No, I'm doing fine. Okay, so this is a cross purge. This would be hooked up to a cylinder. And we'll show a panel too on this. So the idea being you have inert gas like nitrogen come in here, and you can open that up, pressurize it with nitrogen, and then you close it, and then you open the vent valve. So it's a cycle purge.
Yeah. So the gas cycles in.
Yeah.
And then cycles back out, and hopefully it's grabbing some of the stuff.
Yeah.
It's mixing in with some of the bad stuff in here, and it pulls it back out.
The idea being is you're diluting the gas. We're going to show some charts in a little bit.
Oh.
So like he says, it's pressurized. You got contaminated gas in here, and you pressurize it so it mixes. The gas mixes. Mm-hmm.
I mean, think of it like cleaning out your garbage can when it's got a bunch of stuff on it. You try to get it all, and you dump it out, and then it's like, oh, there's still stuff in there. You spray it out, you dump it out.
Dirty garbage can.
You're cycle purging your garbage can, essentially, is what you're doing.
You're not going to fill up once and dump it out.
And dump it out and get everything out of there.
If it's clean, well,
then you're not going to do it.
It's not that dirty to begin with.
So, I mean,
it's like a clean out your garbage can. Do it once, you get and you got to do it again.
Still got leaves in the bottom of it. I didn't get them all out.
Pick them out.
Well,
I'm just. So there's so how many cycle purges do you need? That's the big question. Mm-hmm. So we're going to put up the next graphic. Look at that, a formula.
We love formulas.
We love them.
We love them. Engineers love them.
Regular people are
most of humanity.
I got to do math, and you got sub V's and sub 1s and sub 2s.
Until we get a bigger alphabet, we got to go with the subs.
Yeah, you got to go with the subs. And it's number of cycles. Actually, this is in instructions. We have purging instructions.
Yeah, so this is part of it.
So yeah, we cut and pasted from that. Use the same font and everything.
Mm-hmm. Why break something? Why fix something that's unbroken?
Yeah. So this kind of is a formula if you want to try to figure out how many purges in your concentration. But let's go to the next one.
Well, the key word is in theory. Sorry, the key word in that is in theory.
Yeah.
No, sorry.
Corey did these little graphs that kind of show you here. So these are I'll let you.
No, I can do it. So this is essentially if conditions are perfect. That's why it's in theory. So if you just have like a straight tube and you're drying out gas concentration drop per cycle. If your just venting to atmosphere. So in the first graph, it shows an 80% drop every time.
Well, okay, so that's
with
the blue one.
The blue one, sorry.
So
well,
that first bar
Yeah,
is how much is the first
almost
bar?
100%. So theoretically, you start out at 100%. So 100% concentration, which you wouldn't, but you just 100% of whatever concentration you have.
This purging setup.
This purging setup
is you're purging to atmospheric pressure.
Yeah, I did say that.
And we picked the pressure to be about 60 psi
I was going to get there.
So it's like a 5-to-1 ratio.
Yeah, and if we went back to the...
So it's not like 100. You could do this, like I said, this purge shows you what you're doing at like about 60 psi-ish.
Yeah. So the gas concentration on the blue graph shows an 80% reduction, 60 psi, cycle gas in, 14.7 out to atmosphere.
That's atmospheric pressure.
Atmospheric pressure, so it's an 80% drop. Yeah. Now the key here is that the thing that decides, if you remember the equation, which I don't expect you to, is what does it is the ratio. So the PV is at the bottom, and the initial pressure at the top. So in order to get more, it's easier to lower the number in the numerator or the denominator. Than it is to increase the number in the numerator to get a higher percentage.
So you're explaining the
I'm explaining the equation.
The blue one is for atmospheric pressure.
So if you drop the PV to 2 psi, it increases
that's PSI A.
PSI
so that's like
atmosphere.
under a vacuum.
Yeah. So on Earth we experience 14.7. That's what it is. So if you have ever experienced closing a fridge door and you can't open it again right away, because it feels really hard to open, it's because the pressure in the fridge dropped below atmosphere because of the way the fridge cools. And you can't pull it open. So
the idea being is this is we picked 2 psi-A because that's a typical amount you can get from a vacuum venturi setup on a panel. So you can see that it explained, so that's the orangish graph. You call that color orange?
Yeah.
Okay.
It was meant to be orange. Yeah.
I don't know if you had some fancy name for it.
No, I just picked the color orange. They don't ever tell you what names they are.
Okay, so you want to explain the
so in the orange graph, we decreased the PV.
The venting pressure.
The venting pressure, yeah. I guess we can explain it every time. We decreased the venting pressure, the PV, and that increases the gas percentage loss by a lot, from 80 to 97.75%. And so as you can see, the N+2 in the blue and the N+2 in the orange
just a little sliver.
Just a little sliver, but the difference between that two is huge if you would zoom it up, blow it up.
Yeah, you're really talking line thickness in there.
Yeah. And when it comes to parts per million, which is what we're talking about in these cases sometimes, that little sliver is actually a lot of parts per million.
It's hard to show it on the graph.
Yeah.
Because we were thinking of putting the graph up using percentages and then ppm. Mm-hmm. But that was just numbers, and you can kind of just glaze over. Want to take this graph off? We done with this?
Yeah.
Okay. Okay, great. So if you're going number-wise, if you have contaminant, we just use 100% just to show you how quickly it would drop down. So if pure mixing, you can go from 100% down to about 1 ppm in about 9-10 cycles with a just venting the atmosphere. And if you use the vacuum assist, you're going to do it in probably 4 or 5 cycle purges. So it's much quicker, much better. And this is one of the issues, like Corey was talking about, is that this formula depends upon it totally mixing in there. So if you want to turn this around, so if you're pressurizing it up, you got contaminated gas. The formula says, okay, it's all mixed in there, but if you pressurize this up, maybe it's well mixed at the beginning, and then way at the dead leg, it might not be. It might be just kind of, you're not going to get a good mix, so you might still have some contaminants in there. So there's no real magical number for amount of purges.
Mm-hmm. So you just do it a bunch of times and hope for the best. I mean, no, that's seriously it. That's seriously it, because it's impossible to tell.
Yeah.
You can't unless you can go inside there, extract the gas
you have
out
to
of
look
there.
at your, but yeah, so
You can't.
you have to purge it. So the more you purge it, the better it is.
The only way to perfectly do it is to switch out the gauge each time.
Yeah.
Which is, you know.
Well, no, you just not have it. So we talked about Venturi assist. Actually, part of it is we're gonna show. You see Venturi assist. Don't carry the panel like this. This is.
It's not an Ace Venturi assist.
Yeah, it's not. Okay, so this is our 5500. We call this a 5-valve panel, even though there's 6 valves on there, but it's still a 5-valve panel. So it's got the 5 valves. This is purge gas inlet. That's your vent outlet. That's your regulator isolation. This is your low pressure vent and your process isolation. And this valve here is for, even tells you there, Venturi valve.
What's a Venturi valve, Bill?
It's the valve that goes to the
Venturi?
Venturi.
All right. We cleared that up.
So this is you got nitrogen here. What's nice about a Venturi is you could use a vacuum pump, but then it just gets kind of like, then you're
adding
all
a pump.
sorts of,
You're adding a pump.
then you get all sorts of issues. And you get the bad gas going to a vacuum pump, and then it's like, oh,
You cannot
nightmare.
have to add anything.
So what's nice here is you've got, and it's all Bernoulli's principle as part of the Venturi thing.
Don't worry. We give him a little cut every time we sell
he
one
gets
of
a
these.
cut on
He gets
this
a
thing.
cut.
So you have nitrogen flowing through here, and it creates a vacuum here. So what that does is when you're purging, that's where you get your vacuum. So what's really nice is now this just goes to your exhaust system, and it carries away your contaminated gas. So this acts as your vacuum. So you don't have to, no electricity. You just need an inert gas like nitrogen.
So how do I get this no electricity vacuum in my home?
You can get ones that put on your faucet.
You can. That's true.
That
You
run
can.
water.
That's
So you
true.
can do that.
That's true.
If you want to waste water, you can buy Venturis, put it on your faucet, it creates a vacuum, and you can use that to
There you go.
clean stuff.
And save on electricity.
Yeah, save on electricity. Yeah, waste all the clean water on it. So so that's a Venturi. That's an option that you can get for this kind of setup. It's really nice. So if you really want to get really good purging, you get the Venturi option on your panels. Now, one of the issues, now we talked about gases really need to be, when you're purging it, really should be, you need to have them fully mixed. It takes some time when you're pulling a vacuum to pull down, so you might want to wait a few seconds to get it fully down. And most of our delivery pressure gauges have a vacuum part of it. So it's like -30, 0 to whatever. And so 0 is not at the pin. So you can see when you get vacuum by looking at your delivery pressure gauge, you can see it goes down like that. It doesn't make that sound.
It'd be great if it did, though.
Okay. So we talked about mixing of contaminants. So you might have to take a few more purges to get everything out. The other thing is stickiness of contaminants. It's really moisture. Moisture likes to stick to stuff. Everybody knows that.
Yeah. You ever been sweaty?
Yeah. So you get, brass has more nooks and crannies than stainless steel.
More porous is the.
More porous.
More porous.
Like nooks and crannies.
Like pumice stone.
It's like an English muffin. So
Swiss cheese.
you put butter on there, and it kind of sinks in those nooks and crannies. Yeah. Good luck getting it out.
Oh yeah, that's a Thomas's English muffin commercial right there.
Yeah, I'll tell you.
The nooks and crannies. Oh man, they do not sponsor us.
They're making us hungry. No, they do not sponsor us. So with super high purity systems, semiconductor grade, they will try to get rid of as much nooks and crannies as possible. They'll have special tubing that's really has a really smooth finish to it. They'll be just face seal welded or face seal fittings, so everything's like just nooks and crannies gone. So no place for the butter to stick, or less chances for the moisture to stick anywhere. So yes. Oh, and let's pop up the next slide. We'll talk about moisture in the air. So why you do purging.
Do purging.
So if you have your system and you're concerned about moisture, keep in mind on a very dry day, that's like in the winter in northern Minnesota, it's going to be about 25% humidity, and that's about 6,000 ppm.
Still, it doesn't feel moist to us, but it still could be moist. Feel moist to something else.
Yeah, you still have moisture in your system.
And this is particular for especially corrosive gases that, when combined with water, like hydrochloric acid,
hydrogen chloride.
Hydrogen chloride, you
chlorine.
get water. So this is the reason why most people are concerned about moisture, is because of that reason.
Yeah. So your normal indoors, 40 to 60% humidity, it will be about 1% moisture. So that's when you're changing out cylinders, you can get moisture in there, and you don't want to have that in your system. Mm-hmm. So okay, you take the slide off, and also keep them. And I think we'll skip that stuff.
Yeah.
So
yeah.
This 5000 series, sorry, I had to check. We got a lot of stuff to cover here. So this 5000 series panel has, don't even notice it, but the purge gas coming in, and you really don't need to have the gas blast through there. You know, we're not trying to clean the dust off the table. So we have an orifice in one of the fittings. You don't even know it's in there. It's this compression tube stub setup. It's called a port connector. It's kind of
not a starboard connector.
Yeah, and it's good. You have to really zoom in. But we have an orifice on there, 0.01 inch diameter.
That's tiny.
Okay, it's tough for me to see. So your eyes are better than mine. So what that does is that limits your nitrogen flow rate to 5 to 9 liters a minute coming through there. So you get a nice, gentler flow.
Yeah, because you just want to dry, because it's all about drying.
Yeah. Okay, then we're going to talk about the T-purge.
The T-purge, which it's called a T-purge because it's not a T.
You got to flip it over. I think some people might set it up there.
Did people set it up like this?
I don't know if they set it up there. Or you can call it an upside-down T-purge.
Upside down. Yeah, there we go, upside down.
So
this is cool. I like it because it kind of goes with the principle of you don't want moisture in when the changing of it out.
Turn it around so they can see.
Oh, yeah, duh. But now I don't know what's going on.
Okay.
So when you're changing out a cylinder.
Oh, so this is a CGA connection.
CGA connection right here.
Yeah. And the protective caps, so you don't.
You got protective caps, and so this will be on the regulator. This side goes on the cylinder, and then when you change the cylinder, you can put essentially positive pressure through the system. So
you got nitrogen coming in here,
and so nitrogen will blow out through here as you're attaching the cylinder.
Oh, so that keeps the moisture out.
And that keeps the moisture from letting it go into the line. So the T-purge will do that. And also you can use a T-purge like the purge on the switchover vent. You can also do it to do a line purge as well.
Yeah.
So this is what that's for.
Yeah, you'd have to have some way to vent it.
Yeah.
So there's no.
Yeah, that's the hard part. I mean, unless you want to vent you don't want to, that's the weird part about venting through, is because unless you're going to open up your process system downstream to vent it out somewhere, you're just going to vent it right into it. So it depends on your situation.
Yeah, it depends on your situation. It's not as effective, but it depends. Mm-hmm. Flammable gases are probably really good for this or other thing. It does. If you do it right, you can keep the moisture out, and it depends on your system. Maybe this works well for you. You got the experience using it.
But I think the moral of this whole thing is that sometimes if you go on store.mathesongas.com, we'll offer these things and say, hey, we think this is a good idea for you to do. And we don't do it to sell you a new thing. We do it because it's better for your system. And obviously it benefits us a little bit as well. But it's a good thing. And that's, so. Yeah. It makes your it actually benefits in the long run because your things will last longer.
Yeah, cross purges are great for corrosive gas.
For corrosive, everything lasts longer, and that's the thing. We want you to keep we want you to not have downtime, as much as possible. So that's the goal of us right here. We want you, So
okay. You want to pop up the next slide? We'll show you
we're not done yet.
No, we're done. This is a Jessica slide.
Oh,
there we go.
We're at 25 minutes.
So if you run up the screen and you
there you go.
Put your phone there's some more information. Purging instructions, you can see that wonderful formula. We got videos on cross purge station, shows you how it's set up and purging and stuff. We got a pressure regulator cross purge, and then the bottom stuff is just links to the store. So if you want to get more information on the store, buy something, you can scan that.
There you go.
So okay, you can take the slide down. So that's it for purging this week.
And the next time you're in the market for corrosive gas problems, this is
come here. We got your solution.
Yeah.
So next week, the big question we're going to answer is,
why are we here?
why are we here? why or when do we need a two-stage regulator?
We talk about two-stage regulators all the time, but we never talk about the why of two-stage
why
regulators.
or when? Why would you need one?
The why or the when.
So we're going to talk about that next week.
We're gonna get into the granules.
So tune again next week for another live edition of the Bill and Corey Show.
Set your VCRs.